Hey, little scientists. So, Miss Wallace here. I'm going to talk to you a little bit about the states of matter. Now, I know you have studied states of matter since probably in kindergarten or first grade, but we're going to go a little bit farther into the states of matter and the descriptions of these. So, you have this anchor chart that I've shared with you, and it tells us here that matter is anything that takes up space. So, we think about, okay, well, I take up space, so I must be matter. The tree outside, it takes up space. It must be matter. But a lot of times people think about, well, air. Air doesn't take up space, but it actually does. And you can have an example of that when you blow up a balloon. So air is actually matter, and we know that we call that state a gas. So we've got our three states of matter: solid, liquid, and gas. On your anchor chart here, you're going to see where I've put some pictures to help you figure out which one we're going to fill into the box. So on your anchor chart, you should have a clickable box that you can type into, or if you print this out, you can just handwrite it. So matter can change its states due to changes in temperature or even changes in pressure. So here we have a picture of what looks like ice. So we know that ice is going to be a solid. So let me make this a little bit bigger so it's a little bit easier to see. And down here, we have a picture of looks like a water droplet. So what do you think that one's going to be? Yeah, probably a liquid, right? And then over here, this picture may be a little bit more difficult to tell what it is. It's a liquid. We have bubbles forming. It looks like some steam escaping. And so you're right. That is going to be our gas. Okay. Get that tapped in there. So we've got solid, liquid, and gas. So those are going to be our three states. Now, some of you out there that have been doing your homework, you might say, Miss Wallace, there's really a fourth state of matter, and it's not on here. You're right. You're absolutely right. The fourth state is plasma. We don't talk about that in fifth grade science. You'll get into that a little bit more once you get into junior high and high school. Okay. So the next thing we need to do is we need to describe these three states of matter. So if we scroll down and we look at, we've got a table here. And so we need to put some descriptors of a solid, liquid, and gas. So one thing that we know about a solid is it maintains its shape. So you think of a block of wood, right? It's going to maintain its shape unless you cut it or you do something to change its shape. Physically, it's just going to sit there and it's going to maintain its shape. If we were able to look at the molecules that make up the solid, we would see that they are very, very close together and there's hardly any room for them to move. So the molecules are very close together, right? There's only room for vibrations. Only room for vibrations of those molecules. They are not bouncing around at all. They are maintaining its shape. So a liquid's going to be a little different. We know a description of a liquid is takes the shape of its container. So if I pour water into a tall, skinny vase, it's going to take the shape of that vase. If I pour water into a very shallow, large bowl, it's going to take the shape of that bowl, right? So it changes shape. And it maintains its volume. So 50 milliliters of water is going to stay 50 milliliters of water. So it maintains its volume, right? So it changes the shape, but it maintains its volume. Now, molecules in a liquid are going to be spread a little bit further apart. That's why that liquid is able to move a little bit more. So molecules are spread further. Well, let me spell molecules right. Molecules are spread further apart and allows movement, right? We see that with our liquids. I need to go back over here. I should talk about with a solid, it maintains its shape and its volume. Its volume is not going to change either, just like the liquid, okay? So if we look at our gas just like we said, air that you blow out of your lungs into a balloon, that's in the form of gas. Right now, there's gas all around you. If you take your hand and you just kind of wave it at your face like you're hot and you're trying to cool yourself down, you're going to feel molecules of air striking your cheek. And we know that there's air there because you can feel it, right? So you're moving those little molecules around. And so we know that gas is a third state of matter. Now, it's different than a solid and a liquid in that it does not maintain its shape. It's going everywhere. It's bouncing off the walls in your room. It's bouncing off the walls of your house. So it does not maintain its shape or its volume, right? It's going to go in every little tiny crack that it can find. It's going to try to fill it up. So if we were to look at the molecules of a gas, molecules are spread extremely far apart, bouncing off one another. So there's lots of movement going on here. They're bouncing off one another and objects. And so they're spread extremely far apart. So we have changes in our states of matter, and we're going to refer to pure water when we do a lot in this first unit, because pure water, our temperatures, we're going to refer to pure water. We know it freezes at 0 degrees Celsius. It's going to boil at 100 degrees Celsius, okay? You put anything in that pure water and you are going to affect the freezing point and the boiling point. So now we're talking about changes in states of matter. So you see that we have these other boxes here I've put by these arrows. So let's think for a second. You have an ice cube. You put it in a cup, right? And you just set that cup on your counter. What is the ice going to do? You're right. It's going to melt into water. So this is called melting. Okay. I'm going to make that a little bit bigger. So this is melting. Ice is melting into water. So let's say that you decide to take the water, you put it in a pot on the stove, and we are going to boil the water. So now we have a liquid changing into a gas. So this is going to be boiling, right? Boiling. So we melt from a solid to a liquid. We're going to boil to go from a liquid to a gas. Now, on the reverse of these, and these are the main ones that you need to know. So on the reverse of these, I've got the gas. Now I'm going to change it back into a liquid. This happens when you walk outside and maybe it's been a cool night and there's what we know is dew on the ground, right? It gets your tennis shoes wet. That is condensation. Same thing happens. You take say you got a Dr. Pepper out of the fridge. It was really cold. You set it on your counter. You come back a little while later and there's all this water on the outside of the can. It's because this warm water vapor in the air has landed on that cool surface of your Dr. Pepper can and it's condensed. So this is called, let's get my little keyboard going here, condensation, right? Or condensing. I'm going to put that in here. So condensation or condensing. And that's the reversal of the boiling. So we go from a gas back to a liquid, we're condensing. Okay. Well, what if we want to go back from the liquid to the solid? Well, you know this. You made some Kool-Aid. You got a bunch of Kool-Aid left over and you're like, man, it's hot outside. I think I want to make a popsicle. So what do? You put the Kool-Aid in the freezer, right? So this is what we would call freezing. That is the process of changing the liquid into the solid. Now, you're like, but Miss Wallace, we missed 2 boxes here. Now, these processes we don't talk as much about in 5th grade science, but they do exist, and they're kind of cool. If you get the chance to get some dry ice, they sell it at Brookshire's. It's literally a block of frozen carbon dioxide. Carbon dioxide is the gas that you actually exhale. They take the carbon dioxide, they freeze it, and it turns into what we call dry ice. Okay, it's not water. None of it's water. But the cool thing about dry ice, it goes from a solid straight to a gas. And this is a special process. You may not have heard of it before. It's called sublimation. So I get my keyboard to work. It'll be great. Sublimation, or it sublimates. It goes straight from a solid to a gas. It's wild. It completely skips the liquid, right? And then the reversal of this. So when they make that dry ice, they're taking that CO2 gas, and it's called deposition. And this is where they take a gas and turn it straight to a solid. Now, we are not going to be studying these two. They're interesting. They're very interesting to learn about, but you are not going to be required to know either one of these, okay? One thing we will talk about later on are the temperatures at which these occur. Now, if you want to, you are more than welcome to grab a little box and you can pull it in here. Melting and freezing, going to be at the same temperature, okay? It's a little bit difficult to understand this. We know that if I had pure water and I put it in the refrigerator, if it gets to 0, let's make this number really big, 0 degrees Celsius, okay? I know we like to talk Fahrenheit whenever we are, just talking about the weather or something like that. But 0 degrees Celsius is what we're going to use in science class, because that is going by the scientific system that the rest of the world uses. So if I'm going to freeze pure water, it's going to happen at 0 degrees Celsius. If I'm going to melt pure water, that also happens at 0 degrees Celsius. So that temperature, that number is very, very important. What about boiling? If we're talking about pure water, put a little box right here. Pure water, not water that has Kool-Aid mix in it, not water that has salt in it, just pure water. What temperature do you think? It's a lot more than a 0. It's 100 degrees Celsius. 100 degrees Celsius is what pure water will boil at. Or if we're removing heat, it's going to condense, or condensation is going to happen, okay? So at either one of these, if I'm adding heat, I get to 100, it turns to a gas. If I'm taking away heat, say I turn the burner off under my pot of water, I'm removing the heat, it gets to 100, it's going to start condensing, okay? So 2 numbers you have to remember. This is it, 0 and 100. Don't put any other numbers down, okay? When we do assignments and I ask you melting or freezing point, I don't want to see 50. I don't want to see 32. I want to see 0, okay? So easy to remember these 2 numbers. So I hope this helps. I am always available if you have questions or you need more clarification, and I hope to see you on our weekly Zoom. Have a great day.